Hello students and friends, most welcome to Dr. Acharya Academy. Today I am going to discuss the Gay Lussac's law. Gay Lussac's law is the pressure-temperature relationship. Previously we discussed about the Boyle's law, the relation between the pressure and volume, and second we discussed about the Charles law in the previous class, what is the relation between the volume and temperature. And this is the part of the gas law, Gay Lussac laws, which is a relation between the pressure and temperature. Today's class number is 100. We know, especially in the summer season, whatever the four-wheeler we're using, that tire is inflated with the rising of the temperature in the summer season. So we have to reduce the pressure of the tire during the summer season. Otherwise, the tire could burst. But in the winter season, when temperature is reduced, and the temperature reduced, that means pressure also will be reduced. This is our observation. And in that case, you have to put air in a tire to increase the pressure. So with this common example, we understand that pressure is increased with the temperature and vice versa. That means pressure will decrease with the decreasing of the temperature. So a mathematical relationship is given by the Gay Lussac, which is known as the Gay Lussac's law. And this Gay Lussac law states that at constant volume, the pressure of a fixed amount of a gas varies directly with the temperature. So here you have to remember that at constant volume, you have to mention always. And pressure of a fixed amount of a gas, that also you have to mention. So mathematically, we can write the Gay Lussac's law. P is proportional to T, capital T. Here the T always at Kelvin temperature, that means in the absolute temperature. In just previous class, during the discussion of the Charles law, we introduced this absolute temperature, and from now onwards, everywhere we'll use this absolute temperature, and for the Gay Lussac's law, the pressure is proportional to the absolute temperature. So P by T is the constant, and here this constant is denoted by the K3. If you remember from the previous class, during the Boyle's law, whatever constant is the K1, and after that you can find the Charles law. In that class, whatever the constant has come, we denote is the K2, and for the Gay Lussac law, whatever the constant is there is denoted by the K3. So now you can see this graph. This is the pressure in y-axis and temperature in the x-axis. Temperature is always in the Kelvin scale. You have to remember this, and Kelvin scale don't have any degree symbol. That also you have to remember. And at constant volume and fixed amount of the gas, obviously you have to mention always this, and then the pressure increased when the temperature increased as per the Gay Lussac's law. And here the volume is constant. So when volume is constant, in this line we always call this is the ISO code, this line. Previously you can remember that when I discussed of the Boyle's law, then whatever curve has come, that curve at constant temperature is curve, and then we denote as a isotherm. And the second case, during the Charles law, if you go through the previous class, you can see that whatever the straight line has come, it is against the constant pressure. That's why that line in the graph we used to call the isobar. And this is a third case in the Gay Lussac's law, when always we consider volume is constant, and in this case each line is called as the iso core. I hope this is very small class you understand the Gay Lussac's law, and this law is the pressure versus temperature. Pressure is proportional to temperature. Thank you so much for watching the class.